Welcome to my channel Telugu Vidhyalayam. Today my topic about mechanics of materials. First of all, we need to know what is mechanics of materials. Mechanics of materials is also called as strength of materials. Is a subject which deals with behavior of solid objects subjected to stresses and strains. The study of strength of materials often refers to the various methods of calculating stresses and strains in structural members such as beams, columns and shafts. Mechanical properties. The properties of materials that determine the behavior under applied forces are known as mechanical properties. Strength, elasticity, ductility, malleability, hardness, toughness, fatigue, strength, creep. These are all the mechanical properties. Assumptions of strength of materials. All the bodies are deformable. Materials are perfectly elastic. Materials are isentropic and homogeneous. Principle of superposition is valid. If two or more physical causes are vectorically additive, if the effects are proportional to the cause, the effects are vectorically additive is called principle. Stress. Whenever some external force acts on the body, it sets up a deformation. Let us consider a body, and P is the external force act on the body, and the body in turn offers some resistance against the deformation. This resistance per unit area to deformation. Stress is denoted with sigma. Stress is equals to load by area, and units of stress is Newton per mm square, or kilonewton per meter square, or Newton per centimeter square. Whereas sigma is equals to intensity of stress, A is equals to cross sectional area, P is applied load. Types of stresses. Tensile stress, it is denoted with sigma T. When some load applied on the body tends to pull the material away from each other, causing extension of the body in the direction of applied load. The load is called tensile load, and the corresponding stress is called tensile stress. Let us consider a body, and P is the external force acting on the body. Here we can see the external force acting in this direction, resistance force acting opposite to the applied load. This is portion 1 and this portion 2. Sigma T is equals to R by A. R is nothing but resisting load, and that is equals to P by A. Compressive force, it is denoted with sigma C. When a load applied on the body tends to pull the particle of the material closer to each other, causing shortening of the body in this direction of the applied force. The applied force is known as compressive force, and the corresponding stress is known as corresponding stress. The difference between compressive stress and tensile stress, the direction of load is different. Here we can see the figure. The load is acting towards to the section. This is resting force. Sigma C is equals to P by A. Units of stress is Newton per mm square, kilonewton per meter square. Shear stress, it is denoted with tau or small q. When a load is applied on a body, causes portion of body to slide over the adjusting portion. Such a force to known as shear force, and corresponding stress is shear stress. The portion 1 is slides over the portion 2. That such a force is known as shear force. Tau is equals to resistance force, cross-sectional resistance force by cross-sectional area, R by A or P by A. Strain is denoted with small e. This is the body, and this is force P. When the force is applied on the body tends to change its dimensions. To measure this deformation is called strain. Strain is equal to change in length by original length. E is equals to dl by L strain has no units because length by length, it is length by length, so its units are cancelled. Types of strains: tensile strain, compressive strain, shear strain. Tensile strain is a positive strain. Why? Because it is extension of its original length, so it is positive strain. Compressive strain, it is negative strain. Why? Because it's shortening its length, so it is negative strain. Here we can see the figure. It is body, and we apply the force in this direction. The body moves from here to here. This is the deformation, so it is decreasing the original length, so we get the negative sign. Shear strain. Let's consider a body A, B, C, D. AB is fixed and load is applied in this direction. The CD is deformed, D to D dash, C to C dash with a pi angle. Let us consider shear strain is equals to transfer displacement by distance from lower face, that is perpendicular height. From triangle AD D dash, tan pi is equals to opposite by adjacent. Tan pi is equals to opposite, it is deformation in length, so dl. Opposite is dl, adjacent is length l. For small values of pi, tan pi is equals to pi is equals to dl by l. Volumetric strain. Consider each face of a cube is subjected to equal compressive forces. The result of these forces will be reduction in volume. So EV is equals to dV by V. The ratio of change in volume to original volume is called volumetric strain. Hooke's law. Within the elastic limit, the stress is directly proportional to strain is called Hooke's law. Let us consider stress is directly proportional to strain. Stress is denoted with sigma, and strain is denoted with small e. Stress is directly proportional to E. Here we remove the proportionality. We add a constant C. Sigma by E is equals to constant. The constant is called elastic modulus or modulus of elasticity, or Young's modulus is denoted with capital E. That is, capital E is equals to sigma by small e. Note, Young's modulus has same unit as stress. Why? Because stress has no units. Let us consider sigma is equals to pi by E, but sigma is equals to P by A. We know sigma stress is equals to P by A and strain is equals to dl by L. Therefore sigma is equals to P by A by dl by L. We can write this as PL by dl into A. dl is equals to PL by AE, or dl is equals to sigma into L by A by sigma. P by A is equals to sigma. Here we can see the sum of the materials, its Young's modulus value. Factor of safety. It is the ratio between ultimate stress to working stress. Here we can see the sum of materials and its factor of safety values. Elastic constant. For a material that obeys Hooke's law, the ratio between stress to strain is constant. Depending on the nature of strain, the three elastic constants are modulus of elasticity, modulus of rigidity, bulk modulus. Modulus of elasticity is denoted with the capital E. Modulus of rigidity is denoted with capital G or N or C. Bulk modulus is denoted with capital K. We can modulus of elasticity, the ratio of tensile or compressive stresses to the corresponding strain is called modulus of elasticity. Capital E is equal to sigma by E is modulus of elasticity. Modulus of rigidity is the ratio of shear stress to shear strain and is denoted by capital G, capital N or C. It is also called shear modulus. Shear modulus G is equal to shear stress by shear strain. G is equal to tau by pi. Bulk modulus is denoted with K. If an elastic body is acting upon a three mutually perpendicular direct stresses of equal magnitude, then the ratio of direct stresses to resulting volumetric strain in the body is called bulk modulus of the body. Bulk modulus is equal to direct stress by volumetric strain is called bulk modulus. I hope all of you understand. If you have any doubts, ask in comment box.